Hey everyone, welcome to our video about limiting factors of population growth and also about the human population growth curve. Limiting factors are abiotic or biotic factors that cause a decrease in the population growth. They can either be density dependent, meaning that it matters how many organisms live in a certain area, or they can be density independent, which means that it does not matter how many organisms live in a certain area. Density dependent limiting factors are ones that it matters how many organisms live in a given area, and those things include competition, predation, parasitism, and disease. If you have more organisms in an area, it is more likely that they will have to compete, that they could get hunted, that they could be affected by parasites, or that they could get disease. And since it depends on the number of organisms in an area, it is density dependent. Here are the examples. There's competition. So these birds are going to be competing for space to create a nest. And because they have to compete for space to make a nest, not all of them are going to be able to reproduce because not all of them are going to be able to get space to make their nest. And for that reason, the number of birds in that area actually controls how many birds will be in the next generation. That's competition for space. Predation is a density dependent limiting factor. The number of prey is determined by how many prey there are, because as the number of prey increases, the number of predators is going to increase. And then because the number of predators increases, the number of prey will decrease because they're being hunted. And as the number of prey decreases, so does the number of predators because they don't have enough food. But then as the number of prey increases again, guess what? So do the number of predators. And so the predation or hunting of organisms is completely density dependent. It depends on how many predators there are and how many prey there are in a certain area, and that can limit populations. Parasitism also is a density dependent limiting factor. Parasitism is a density dependent limiting factor because if there are more hosts in a certain area, it is more likely that the parasites will be able to survive and reproduce. So, this has become a problem in this area because we have a very high population of deer. And we have such high density of deer that deer ticks are able to survive very, very easily in this area because they are able to feed on the deer that are here. The high density of the deer means that there can be a high population of ticks. And because there are a high population of ticks now, that could start to limit the population of deer because the ticks are able to spread disease from one deer to another. Disease is also something that is affected by the population density. We know this because we've recently seen it in coronavirus. We've seen that areas where there is a high population density, like Northern Virginia and Washington, D.C., and Richmond, are having a much harder time with diseases like COVID 19 than areas like Salem, which have a relatively low population density compared to Richmond or Northern Virginia. But this has also been shown with other diseases, such as frogs, and they're dealing with the chytrid disease. Um, the more frogs there are initially, the more likely they are to quickly spread disease, and the more likely that disease is to be able to impact or reduce the number of frogs in that situation. So, competition, predation, parasitism, and disease all depend on how many organisms are living in a certain area. For that reason, they are all density dependent limiting factors. Density independent limiting factors do not care about how many organisms are living in a certain area. And a lot of these are abiotic factors like weather and natural disasters and seasonal cycles. And some of them are biotic, like human activity, such as putting dams at rivers or clear cutting forests. But in all of these situations, it does not matter how many organisms live in a certain area. These limiting factors can impact large or small populations. Here's just some pictures of that. If you have very dry weather or a drought, it doesn't matter if there were a ton of sheep there or just a few sheep. That drought is going to impact that population. Here is a natural disaster like a wildfire. It does not matter how many deer live in this area. If it's very few or very many, this wildfire is going to impact them no matter how many organisms live there. Weather is an event here that's happened. This hail did not care how many plants were in this field. The hail was going to fall and destroy them all. This is a human-caused density-independent limiting factor, clear-cutting a forest. We clear-cut that forest regardless of how many squirrels, raccoons, possums, other organisms live there. We clear-cut it. It didn't matter how many lived there. They were all affected. And here's another human example, damming a river. So before, there used to be a lot of land here, and it was just kind of a narrow river, but we built this dam, which flooded a lot of area and caused there to be a lake here rather than land. Did we care how many different species lived there? No, it didn't matter how many were there. They were affected by this density independent limiting factor. So the common theme in all of these pictures is it did not matter how large the population was to start with in a given area. That population was affected by all of these different density independent limiting factors. This is an example of human population growth. So we're kind of switching gears here. We've talked about limiting factors, but we're completely switching and talking about human growth. Now, human population growth has been kind of interesting. Initially, it was very slow due to some limiting factors. We didn't have the technology to get as much food as we needed, and we kind of had to deal with that. And there's a small population increase in humans once we had plowing and irrigation, so early farming. The bubonic plague decreased human population pretty significantly, but then the Industrial Revolution took place. And once the Industrial Revolution took place, human population grew exponentially, and it's continuing to grow exponentially. So, about 500 years ago, we really started to increase in human population, and that was boosted by the Industrial Revolution, which was about 150 to 100 years ago. Our population is now growing at a very, very high rate. And some scientists are worried about that because when your population starts to grow at a high rate, you might start to encounter some of the density dependent limiting factors, such as disease, like we're seeing with COVID-19. This is just some example of different birth rates, death rates, and age structures of populations in different countries, and that can kind of show why some countries have high growth rates and some countries have low growth rates. So if we look at Nigeria, there's rapid growth in the population. There are every year more and more and more people in Nigeria because there are very few elderly people and many young people, and young people tend to reproduce more. So once people reach, this 15 to 19 age group, they might start having babies of their own, which further increases the numbers in the population. In the United States, we do have a growth rate that is positive. We are continuing to grow as a population, but it is much slower than Nigeria. We still have a good number of older people in our society and middle-aged people in our society. Our society in the United States is tending to remain about neutral, but growing slightly. In Germany, there's actually a decline in growth. Their population is going to eventually start decreasing because there are more people in the older generation and much fewer people in the younger generations. That means these guys are pretty much done reproducing, and there aren't that many young ones that are going to start reproducing in the next generation or so. So, if we look at the age structures, we can kind of see why certain countries are growing quickly, like Nigeria, why some are remaining stable, like the United States, and why some are declining, like Germany. Thanks so much for listening.